I could imagine that even the earliest human beings, or possibly pre-human beings, had asked themselves the questions, why am I here? What is the nature of reality? Why is the universe organized the way that it is? And these questions are what we attempt to answer in the field of physics. Which you could view maybe right after mathematics as the purest of the sciences. So you have math, which is very pure. And then on that foundation of math, you have physics. And physics really does try to use that mathematics along with some core ideas to explain the phenomena, all the phenomena of the universe. And physicists will be the first to admit that they are just beginning to understand the nature of reality, the nature of everything around us. Now, a lot of times we think physics is only limited to things like cosmological phenomena, or getting rockets into space, or how waves move, or building structures. But physics is the foundation for all of the other sciences. When we think about chemistry, which is at the end of the day interactions between atoms, those interactions are really physics-based interactions. So chemistry is actually laid down on a foundation of physics. And then even when we think about ourselves, our bodies, even our consciousness, our brains, it really all boils down to chemistry and physics. It boils down to interactions between atoms and even mechanical properties of our bodies. And so even biology, even what we are, is built on a foundation of chemistry. So this is biology right over here, which is built on a foundation of physics, which is highly dependent on some of the math that you've been learning your whole life and that you will continue to learn. And that fundamental question that you might have said, well, hey, why am I learning this math? Well, one, because the math is beautiful, but also you will see that it starts to, in almost the most pure way, describe the structure of the universe. And we're going to see that more and more and more as we go into physics. All of this complex phenomena that you see around us, whether we're looking at a galaxy or we're looking at ocean waves, or we're looking at even biological systems, we'll see that a shocking amount of them can start to be described using some fairly elegant mathematics that we can build on and continue to build on. Simple or elegant mathematics like force is equal to mass times acceleration. And we're going to talk about force and acceleration as vector quantities. We're going to think about things like displacement, and I'll put it as a vector quantity, and we'll soon learn more about what vector and scalar quantities are. Displacement is equal to velocity times time. We'll learn things like acceleration is equal to change in velocity over change in time. And what we'll see with even a handful of very simple ideas like this, and we'll go into much more depth in future videos, you can explain all sorts of complex phenomena. And the one thing that I always loved about physics, and I don't think it's always fully appreciated, sometimes as you start to learn physics, you'll see all of these complicated formula, all of these kind of complicated problems, but it's super valuable to realize it's all coming from some of these basic ideas, some of the things that I just mentioned. These ideas, we're going to explore ideas of energy. We're going to explore Newton's laws. We're going to think about what are all the different types of forces out there and why they might actually exist. And at its essence, it's all about trying to explain the complexity of the universe, predict what is going to happen based on simple ideas. And that's what physics is all about. Now, when we think of physics, it's been studied by humanity for a very, very long time. In fact, I'm sure we don't know who the first physicists were. But some of the I guess you could say foundational thinkers in physics are these gentlemen that I have here. And this is just maybe you could kind of say this is some of the most prominent thinkers in physics, but this is by no means a complete list. First and foremost, we'd want to include Isaac Newton. Especially when you start to study physics, you're starting to understand the world as Newton understood it. He understood, hey, things don't fall to the ground just because they always fall to, just because that's the way the universe is. That's a force that's acting on it. And maybe that same force that's causing me to be stuck to my chair right now is what keeps Earth orbiting around the sun, or the moon orbiting around, or the moon orbiting around the Earth. He developed law of gravitation gravitation, Newton's laws, and we're going to study that as we delve into our basic physics. And what we'll see, even classical mechanics, the physics that Newton established, can explain a large range of phenomena with amazing precision. But as we get into the early 20th century, physics starts to get even more wild as we start to look at the scales of the super small, and we have Max Planck giving us quantum mechanics. And then we have Albert Einstein as we start thinking about super fast speeds, the speed of light, and we realize it's an absolute, that nothing can travel faster than the speed of light, which is this mind-boggling thing, that we have this notions of general and special relativity, and we start realizing that the universe is in some ways more bizarre and more mysterious and more fascinating than we ever could have imagined. But all of the work, even to understand the modern physics of Max Planck and Albert Einstein, it's based on a lot of the core ideas that were given to us by Isaac Newton, even people before Isaac Newton. So as you go into your study of physics, and I'm kind of a physicist wannabe. I wanted to be a physicist. I imagined kind of, because it's all about, we all wonder, why are we here? What is the nature of reality? Why do things happen the way they are? And these are the questions that physics is attempting to answer. And so as you go into your study of physics, I want to leave you with some quotes from these three gentlemen. So the first two are from Isaac Newton. Truth is ever to be found in simplicity, and not in the multiplicity and the confusion of things. And I really wanted to stress this because a lot of times in your studies you might be finding yourself memorizing formulas and vocabulary, but that's, if you're doing that, you're just at the very surface. But if you really start to think about it and really start to think about where these things come from, it'll come to simpler and simpler and more intuitive ideas, and then you are getting closer to the truth. Now, I love the second quote from Isaac Newton. I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. I like to imagine, there's so much, even though we think we know so much, that we haven't even learned a small fraction of how the universe really is. And even a great thinker like Isaac Newton, he recognized this. He's like, hey, I'm just kind of dabbling into the seashore and picking up a pebble there, but there's this vast ocean that I can't even begin to understand. You can even imagine alien civilizations that are thousands of years ahead of us technologically or scientifically, or even millions of years, how they might perceive the reality, and they might see us as ants, and we are just beginning to scrape the surface of how the world works. This is from Max Planck. When you change the way you look at things, the things you look at change. And I find this to be pretty profound because it is true. As you study physics, you will start to see, well, most of what we consider to be reality, our current understanding is based on these forces. But what are these forces? And even these things that we think are solid, when we go down to the atomic level, we see it's mostly empty space, and it's really just the interaction of forces that make us think that something is solid or there or tangible in some way. And you realize these very tangible things aren't so tangible after all. And at the end of the day, the whole world is just a mental model that we have. It's in some ways it's an illusion that our mind creates so that we can operate inside of it, but we're just beginning to understand it. And last but not least, and there's actually a ton of great quotes from these folks and others, but especially Albert Einstein, the most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science. And I really want you to take this to heart as you study your physics. There will be times where we're going to be building our toolkits. What's a vector? What's a scalar? Going into some mathematics, proving some formulas. Those are the toolkits, but then we're going to try to understand fundamental phenomena. How does the universe actually work? And if when we start to think about these, you don't get a few chills on your skin, a few goosebumps, and feel that the universe is more mysterious than you thought, then we're not studying physics the way that we should be studying physics.